Hello and welcome to Astronomy Daily, the podcast that brings you the universe one story at a time. Give us 10 minutes and we'll give you the universe. I'm Avery.
And I'm Anna. It's great to be with you. Today we'll be talking about SpaceX's updated plans for the Starship lunar lander and how a distant star's tantrum could be the key to finding alien life.
That's right, Anna. We'll also dive into a massive, previously unseen stellar stream discovered by the Vera Rubin Observatory, a tiny CubeSat on a mission to deep space, and Europe's ambitious new plans for reusable rockets. Let's get started.
Our first story takes us to the forefront of lunar exploration. SpaceX has been under immense pressure to deliver its Starship lander for NASA's Artemis program, and it seems they're adjusting their strategy.
Adjusting is one word for it. They've announced they're developing a simplified lunar landing mission architecture. In a statement on October 30th, the company claimed this new approach could get astronauts to the lunar surface faster than the current, very complex plan for Artemis 3.
Faster is certainly what NASA wants to hear. The original plan involves a whole series of refueling launches in Earth orbit before Starship can even head to the moon. The complexity is a major reason for the delays.
Exactly, and NASA has been very public about those delays. Back in July, Lori Glaze, a top official at NASA, noted that key milestones anticipated for this year were clearly slipping. SpaceX seems to be responding to that pressure, but they've been cagey with the details on what this simplified mission actually looks like.
Right. They're defending their progress while simultaneously changing the plan. The company did give a new timeline, stating that the timing will be driven by upcoming flight tests of the new Starship V3 architecture. They're targeting both the uncrewed and crewed demonstration landings to take place in 2026.
2026 is an aggressive target, especially with the original Artemis 3 mission slated for late 2025, a date that almost everyone now agrees is impossible. It seems SpaceX is trying to reset expectations while still aiming high. We'll be watching those V3 flight tests very closely.
Indeed. From landing on our moon to the potential origins of life on other worlds, our next story is truly fascinating. For the first time, astronomers have witnessed a coronal mass ejection on another star in its entirety.
A CME, like the solar storms our own sun produces. But this wasn't just any star. It was a young, active one. And the energy this thing packed was immense. Scientists believe it's enough to potentially kickstart the chemistry of life on any planets that might be orbiting it.
It's a beautiful yet violent concept. We often think of these powerful stellar outbursts as dangerous to life, capable of stripping away atmospheres. But this research suggests that for a young, lifeless planet, a powerful CME could provide the energetic spark needed to forge complex molecules, the building blocks of life.
That makes sense. It's a cosmic chemical reaction. The article calls these observations a rare insight into the role stars can play in the origin of life. It's possible our own sun did the very same thing for Earth 4.5 billion years ago.
Precisely. So while we search for life on other worlds, we might need to look for planets around stars that are going through these violent, energetic phases. It's a paradigm shift, seeing a stellar storm not just as a threat, but as a potential creator.
Amazing stuff. It really makes you think about how delicate, yet how resilient the process of life's beginning must be.
Let's move from the beginning of life to the ghosts of galaxies. The Vera Rubin Observatory hasn't even officially started its main survey yet, but it's already making incredible discoveries.
That's the most exciting part. This was during its commissioning phase, basically just testing the camera. In June of 2025, it took what are called its Virgo First Look images, and astronomers found something huge.
An enormous stellar stream. These are the remnants of smaller dwarf galaxies or star clusters that have been torn apart by the gravity of a larger galaxy. This particular stream was found emanating from a galaxy called Messier 61 in the Virgo cluster.
And when we say enormous, we mean it. The newly discovered stream is about 163,000 light years long. That dwarfs most other streams we've found. To put that in perspective, our own Milky Way galaxy is only about 100,000 light years across.
It's just staggering. The authors of the study even noted how remarkable it is that a stream this massive went unnoticed for so long, especially around a well-studied Messier galaxy.
Totally. It just shows how much is still hiding in plain sight. They conclude by saying they expect a treasure trove of substructures to be unveiled when the Rubin Observatory's full survey begins. If this is what they find just by turning the camera on, I can't wait to see what the full survey reveals.
It will be a new era for astronomy. Now, from one of the world's largest telescopes to one of the smallest spacecraft, the European Space Agency is preparing to launch HENIN, the first CubeSat designed to independently journey into deep space.
A tiny satellite with a huge mission. HENIN isn't just going into Earth orbit, it's heading out to a distant retrograde orbit, or DRO, around the Sun. This is a special, stable trajectory first proposed way back in 1969 by a French astronomer named Michel Hennon.
Right. And from this unique vantage point, HENIN will act as an early warning system. Its instruments are designed to detect solar storms hours before they reach Earth. This could be a game changer for protecting our satellites and power grids.
A big one. Currently, our best warning times for a solar storm are under an hour. HENIN could potentially increase that warning time to as much as 6 hours. That's a lot of extra time to prepare critical infrastructure.
It really is. This mission is a milestone for small satellite technology. If HENIN can demonstrate this capability, it will pave the way for a future constellation of small, relatively inexpensive spacecraft that can keep a constant watch on the sun, giving us a much more robust defense against dangerous space weather.
That autonomy is absolutely key. It demonstrates that small, relatively cost-effective platforms can now perform complex, high-stakes deep space missions that were once the exclusive domain of large billion-dollar probes.
This really opens up a new paradigm for solar system exploration, and especially for building resilient constellations for space weather monitoring, giving us eyes on the sun from multiple angles.
A tiny sentinel standing guard millions of miles away. I love it.
Finally, for our last story, we turn our attention back to Earth, specifically to the launch pads of Europe. Ariane Group is making a serious push to develop its own reusable rocket technology.
This is a big deal for them. For years, Europe has relied on expendable rockets like the Ariane 5. But with companies like SpaceX dominating the launch market with reusable boosters, they know they need to catch up. This new effort is built around an engine called Prometheus.
That's right. Prometheus is a reusable, high-thrust, but low-cost engine that burns methane and liquid oxygen. It's the powerhouse that will drive a series of demonstrator vehicles designed to test the technologies needed for vertical landing and recovery.
The roadmap is ambitious. They're aiming for a full-stage recovery demonstration around 2027 or 2028. If that's successful, an operational reusable rocket could follow in the early 2030s, assuming they continue to get funding from the European Space Agency and other partners.
And the goal here is clear. Ariane Group states that the program aims to boost European autonomous access to space. They don't want to be reliant on other countries or companies for launching their critical satellites.
Sovereign capability. It's a race not just for commercial advantage, but for strategic independence in space. It will be exciting to see if Prometheus can help Europe leapfrog into the reusable era.
Leapfrog is the perfect word for it. They aren't just trying to copy existing reusable designs. The Prometheus engine is being designed from the ground up for extreme low cost and rapid production, using advanced manufacturing techniques like 3D printing for many of its core components. If they succeed, they could create a rocket that's not only reusable, but also significantly cheaper and faster to build in the first place.
And that kind of robust competition is fantastic for the entire global space industry. It drives down launch costs for everyone, it fosters rapid innovation, and ultimately it gives humanity more affordable and reliable access to space for science, commerce, and exploration. A strong, competitive, and independent European launch capability is a benefit to the entire international space community.
It really shows the incredible breadth of what's happening in space exploration right now. We have public-private partnerships pushing the boundaries of lunar travel, while fundamental science is rewriting our understanding of how life might begin. The scale of it all is just breathtaking.
It is, and at the same time, we're developing new tools from giant observatories to tiny satellites that are giving us a clear picture of both the distant cosmos and our own solar neighborhood. Every story we cover today is a piece of that larger puzzle of discovery. It's a very exciting time.
And that brings us to the end of our episode. From revised moon missions and life-giving stellar storms to galactic ghosts, tiny sentinels, and the race for reusable rockets, it's been another busy week in the cosmos.
It certainly has. Thanks so much for joining us on Astronomy Daily. We hope you'll tune in next time for another journey through the latest news from our universe. Until then, I'm Avery.
And I'm Anna. Keep looking up.